Hello everyone. In this video we are going to see the projection of planes. Rather than saying projection of planes, the actual topic is actually orthographic projection of planes. Before planes we would have already seen projection of lines and projection of points, and just before projection of points, so we would have seen a topic called as orthographic projections or principles of orthographic projections. So there we would have learned regarding so there are different types of projections like orthographic projection, isometric projection and so on, and there are oblique projections and perspective projections. So there are different types of projections, and the word ortho means 90 degrees or viewing something at exactly perpendicular or 90 degrees. So here though we are not mentioning the full name orthographic projection of planes, okay, but it is actually orthographic projection of planes. Okay, so that means whatever the type of plane it is, so we are actually looking perpendicular to the object. Okay, that means we generally know that here I have given the definition for a plane. Okay, so the definition for a plane, or before that we have seen lines. Okay, so the line is nothing but the shortest distance between 2 points. Okay, so when number of lines are connected in some manner, okay, it forms different types of planes. So here I have given some of the examples. Okay, and before seeing that examples, so I want to tell what is the definition of a plane. Okay, so plane is defined as a two-dimensional object. Okay, so in simple, a plane is nothing but a two-dimensional object, so where it has only length and breadth. The thickness is always neglected. So everybody, most probably it will have some thickness. Okay, if you take a paper, okay, even that paper also has some thickness, but the paper can be considered as a plane. Okay, why? Because the thickness is negligible when compared with the length and breadth. Okay, so here as the definition says that a plane is a two-dimensional closed object having length and breadth only. Its thickness is always neglected. Okay, so like I said, the thickness will be there, but when we are considering, or when we are not when we are neglecting the thickness, so then only that particular thing can be called as a plane. Okay, so various shapes of the plane figures are considered, so for solving the problems or for understanding the concept of projection of planes. So here I have put up some of the planes examples depending upon its geometrical shapes. Okay, and the first one is triangle, okay, and square, rectangle. So these are the basic shapes which we know already in the school itself. In geometrical constructions we might have drawn all these particular kind of figures, geometrical figures. Okay, triangle, square, rectangle, pentagon, rhombus, hexagon, circle and semicircle. So these are the some of the geometrical shapes which we are going to use. So to understand the concept of projection of planes, or in other words what I can say is in what way the planes are actually put with respect to the horizontal plane and vertical plane, and where we can see the true shape of that particular plane. So that and all we are going to see. So these are some of the examples of the planes. And in projection of planes what we are going to do. Okay, so in this topic, so the problem is generally given as to draw the projections. So the drawing the projections means, so we are supposed to draw the front view, top view, and in some problems specifically they may tell that we are supposed to give the, or we are supposed to draw the side view also. Okay, so here the projection of planes, so depending upon, like the problem is asked on hexagon, the problem may be asked on pentagon. Okay, so like that different kinds of planes are there, and what will be given is its position will be given with respect to the horizontal plane and vertical plane. So in when we read a particular problem related to projection of planes, so there the geometrical shape of the plane will be mentioned, and that particular plane position with respect to horizontal plane and with respect to the vertical plane will be given, and we are supposed to draw its projections. So drawing the projections means, like I mentioned, so we are supposed to draw the front view and top view. So these two are the common things that we will be drawing for all the planes. Not only all the planes, if you are taking lines, if you are taking points, if you are taking solids. Okay, so we will be drawing the projections. So that means we are drawing the front view and top view, and in some problems specifically they may ask you to draw the side view also. Okay, so here what are the different positions of the plane? Okay, so for lines there are different possible positions with respect to the horizontal plane and vertical plane. Similarly, the plane also has different possible positions with respect to the horizontal plane and vertical plane. So here I have mentioned all the possible positions. So for a plane, we can have 6 possible positions with respect to the horizontal plane and vertical plane. So the first position is a plane parallel to HP and perpendicular to VP. So plane parallel to HP and perpendicular to VP, plane parallel to VP and perpendicular to HP. So the thing is, in the first slide what we have seen is, we have seen different types of planes examples. So if you consider a triangle, so if I give the name of the triangle as ABC, the area which is bounded between ABC lines, so AB, BC and CA lines, so that entire area is called the surface of the plane. Okay, so and A is, I can mention it as corner A, B as corner B, and C as corner C, and AB as edge AB, and BC as edge BC, and CA as edge or side CA or AC. Okay, so depending upon the surface of the plane, the entire area of the surface of the plane, so what we are going to do is, we are going to tell its position with respect to horizontal plane and vertical plane. So here plane parallel to HP means the entire surface should be parallel to the horizontal plane. The entire surface should be parallel to the horizontal plane. Suppose if I take an example of a paper here, I am holding a paper. Okay, so I am considering this rectangular thing as a plane, because I am going to neglect the thickness of this particular plane paper. Okay, I am going to neglect the thickness, and you already know that this is a two-dimensional thing. Okay, so it has some length and it has some breadth. Okay, so when I say that this particular plane is parallel to HP, when all the 4 edges, okay, so you can see that the rectangle that I am holding here will have 4 edges. Okay, so 2 longer edges and 2 shorter edges will be there. Okay, so when all these 4 edges, or when all these 4 corners of this rectangle are having same distance with respect to HP, so then this particular plane is called as parallel to HP. Okay, when it is parallel to HP, so automatically it is perpendicular to VP. Okay, so this is the first possible position of a plane, and the second possible position is parallel to VP and perpendicular to HP. Okay, so this is the position. Okay, so this is the position, plane parallel to VP and perpendicular to HP. So why I am calling this particular rectangle position as parallel to VP? Because all these 4 corners of this rectangle, or all these 4 edges of the rectangle, are having the same distance with respect to the vertical plane, so then it can be called as parallel to VP. So if it is parallel to VP, it is perpendicular to HP. Okay, and the third possible position is plane perpendicular to both. Okay, it is not parallel to VP, it is not parallel to HP, it is perpendicular to both HP and VP. The position will be something like this. Okay, so the plane is actually parallel to the PP. So PP is nothing but profile plane. Okay, so what is profile plane? So it is an area where we project the side views. Okay, you might have already known that the front views are projected on the horizontal vertical plane, the top views are projected on the horizontal plane, and now I am telling that the side views are projected on the profile plane. Okay, profile plane is an area so where we project the side views. So I am telling that this particular position is parallel to PP. Okay, it is not parallel to HP, it is not parallel to VP, rather it is parallel to PP, profile plane. Okay, how it is with respect to horizontal plane and vertical plane? It is perpendicular to both. So when it is perpendicular to both, in the top view you can see it as a line, in the front view also you will be seeing it as a line, whereas in the side view you can see the true shape of the plane. So that is the third position, plane perpendicular to both HP and VP. Next, fourth one is plane inclined to HP and perpendicular to VP. So this particular position I can call it as plane inclined to the horizontal plane and perpendicular to the vertical plane. Okay, so here when it is like this, it is inclined to, it is parallel to HP. Okay, when I said like all these 4 edges or all these 4 corners are having same distance with HP, it is actually parallel to HP. Now this time it is not having the same distance, now it is having different distance. Okay, so this entire plane surface, okay, so is actually inclined to the horizontal plane. So is inclined to the horizontal plane, and with respect to the vertical plane it is actually perpendicular. Okay, so now what we are going to do is, so either in the front view nor in the top view we can actually see the true shape. Okay, so if a plane is inclined to one particular plane, what we cannot do is we cannot solve the problem with just one front view and one top view. Okay, we need actually two front views and two top views. So what we are going to do here, since the plane is inclined to the horizontal plane, so we are supposed to make the plane parallel to HP in the initial position. So for whichever the plane this actual rectangular plane is making the inclination, okay, for that plane we have to make this rectangular plane parallel. Okay, so that means if the inclination is given to HP, make the plane parallel to HP. If the inclination is given to VP, make the plane parallel to VP. Okay, so this is the fourth position, actually inclined to HP. Since it is inclined to HP, what you are supposed to do, you are supposed to make it parallel to HP. In the top view you will get the true shape, in the front view it will appear like a line. Okay, in the third position or in the third figure, what we are supposed to do is you have to take this particular distance which is appearing as a line and you have to put it inclined to the horizontal plane. So those visuals are there with me, so we are going to see in 1 or 2 minutes. Okay, there you will clearly understand what is inclined to HP and what is inclined to VP. And fifth position is plane inclined to vertical plane and perpendicular to horizontal plane. So this is actually parallel to VP. Now this is inclined to VP. Okay, inclined to VP, and how it is with respect to HP, it is perpendicular. Okay, so when the plane is inclined to VP, what we are supposed to do, for in the initial position, like I already mentioned, when a plane is inclined to one particular plane, we cannot solve it in one front, we cannot solve it with one front view and one top view. Okay, so that's why what we do is we make it parallel to whichever the plane the inclination is given. Okay, so here the inclination is given to the vertical plane, so that's why what we are doing, we are making plane parallel to VP. Okay, in the front view you can see the true shape, in the top view it will appear like a line. Okay, that line kind of thing, so the distance you are supposed to make inclination to the vertical plane, and finally in the front view you are going to get the reduced shape of the plane. And the last position is plane inclined to both HP and VP. So when a plane is inclined to both HP and VP, okay, so in the front view also you cannot get the true shape, in the top view also you cannot get the true shape. So how many front views and how many top views are needed to solve the last position problem? Okay, so you need 3 front views and you need 3 top views to actually solve the problem. Okay, so plane inclined to both HP and VP. And the most important thing that you have to consider for solving the problems related to projection of plane which is inclined to both is, so you have to look for a word called as surface. In most of the double inclination planes problems, so what is mentioned is two inclinations will be there, because the inclination is for both HP and VP. Okay, out of the 2 inclinations, one inclination will be given for the entire surface. In most of the problems it will be like this, one inclination will be given for the entire surface and the another inclination will be given for the edge. Okay, so that's what the last position, which is nothing but plane inclined to both HP and VP. So now we will see one by one in which we are going to see the true shape depending upon the position of the plane. Okay, so the first position is plane parallel to HP and perpendicular to VP. So here I have taken the example as a rectangular plane. Okay, that yellow thing which is inside that 4 red color lines. Okay, so that is, this is nothing but your rectangular plane, so which is parallel to HP. Okay, so these 4 corners ABCD or the edges AB, BC, CD and DA, so they are actually having the same distance, so with respect to the horizontal plane. That's why, so the plane can be said as, the plane position can be said as plane parallel to HP and perpendicular to VP. Okay, so here with what view we will start first, so that's very important. Okay, so with what we will start, in whichever the view you are able to see the true shape, true geometrical shape. If I say a pentagonal plane, what is the true shape? It is nothing but a pentagon. If I say a circular plane, okay, what is the true shape? So it is nothing but a circle. Okay, so if I say a rectangular plane, if I say a triangular plane, the true shape is nothing but a triangle. Okay, so like that, here I have taken the example as a rectangular plane which is parallel to HP and perpendicular to VP. Okay, so in what view I can see the true shape? So here I have put 2 like heads. Okay, so one is for the front view and another one is for the top view. So here depending upon the direction, this red color is for the front view and this red color is for the top view. Okay, so when this particular position of the plane, so which is parallel to HP and perpendicular to VP, So when it is looked from the top view, so then only we can see the true shape. So then only we can see the true shape, that too on the horizontal plane. And when this same position is seen in the front view, so it will be appearing like a line. So the solution for this particular figure is already mentioned here. Okay, so xy reference line, and on the top of the xy reference line, the entire area is nothing but your vertical plane. And on the vertical plane, so we are going to project the front view. On the horizontal plane, we are going to project the top view. So you can see the three-dimensional representation of this particular quadrants here. Okay, first quadrant. Okay, so in the top view, since I can see the true shape, so this is how I am going to draw my final solution for the first position, that is plane parallel to HP and perpendicular to VP. So when a plane is parallel to HP and perpendicular to VP, you have to start the figure with the top view first. So why with the top view? Because the true shape can be seen in the top view. How it will be seen in the front view? It will be seen as a line. Okay, so and second position is exactly opposite to this one, plane parallel to VP and perpendicular to HP. I already told you that all the four corners A, B, C, D, if they are having same distance with VP, it is called as parallel to VP. Okay, so when the plane is parallel to VP, so with what view we will start first? So with the front view. Okay, because you can see the true shape in the front view. In the top view it will appear like a line. Okay, so left side you have the three-dimensional representation of this particular position of the plane, and on the right side you have so I can tell this particular left side thing as the pictorial representation, whereas on the right side I can tell that this is the orthographic projection or orthographic representation of this particular position. Okay, so in the front view, so we are going to draw the rectangle, and the top view it will appear like a line. So you already know that right in the planes and right in the points and lines. Okay, if a point is A, capital A, its front view will be small a dash, its top view will be small case a, and the side view will be small a double dash. Okay, and the third position is plane perpendicular to HP and VP. So you can see that, so this light brown color kind of thing, so it is nothing but your profile plane, so where our side view is actually projected. Okay, so here once again this yellow color thing is nothing but our plane which is perpendicular to both HP and VP. So when the observer is looking in the front view and in the top view, so the front view will be appearing like a line, the top view also will be appearing like a line. So whereas this particular thing, okay, so this one is for the side view. Okay, so this side view is seen are projected on the profile plane, and in the side view only we are going to see the true shape. So the solution for this particular figure is mentioned here. So first you are supposed to draw the side view. Why we are going to start with the side view first? Because the true shape is seen in the side view. So first we are going to draw with the side view, start with the side view, and after that, so we are going to draw its front view or top view. Okay, so this is the third position of the plane.